A sectional chart is a type of aeronautical chart published by the FAA that provides detailed information about airspace and ground features within a given geographic area. Sectional charts are used by pilots, including drone pilots operating under FAA Part 107 regulations, to plan flights and navigate the airspace. Sectional charts cover a specific area and are typically printed on a scale of 1 by 500,000, meaning that 1 inch on the chart represents approximately 8 miles on the ground. The chart provides a wealth of information, including airspace boundaries. Sectional charts show the location and boundaries of different types of airspace, such as Class B, C, D, and E airspace, as well as special use airspace and restricted areas. Terrain and ground features. Sectional charts show the terrain and ground features within the coverage area, including mountains, hills, rivers, lakes, cities, and other landmarks. Airports. Sectional charts show the location of airports within the coverage area, as well as information about runway lengths and orientation, communication frequencies, and other operational details. Drone pilots operating under FAA Part 107 regulations are required to use sectional charts to plan their flights and ensure compliance with airspace regulations. By understanding the information provided on sectional charts, drone pilots can better navigate the airspace and ensure safe and successful operations. FAA Part 107 regulations require drone pilots to be familiar with latitude and longitude, which are two key coordinate systems used to identify locations on the Earth's surface. Latitude refers to the angular distance between a point on the Earth's surface and the equator, which is defined as 0 degrees latitude. Latitude is measured in degrees, with values ranging from 0 degrees at the equator to 90 degrees at the north and south poles. Longitude, on the other hand, refers to the angular distance between a point at the Earth's surface and the prime meridian, which is defined as 0 degrees longitude and passes through Greenwich, England. Longitude is also measured in degrees, with values ranging from 0 degrees at the prime meridian to 180 degrees at the international dateline. Together, latitude and longitude provide a precise way to identify any location on the Earth's surface. For example, the latitude and longitude of the Statue of Liberty in New York City are approximately 40 degrees north and 74 degrees west, respectively. Drone pilots operating under FAA Part 107 regulations may need to use latitude and longitude to plan flights and navigate in the airspace. For example, they may need to input the latitude and longitude of their flight area into flight planning software or use GPS coordinates to navigate to a specific location during a flight. Understanding how to use latitude and longitude is an important part of complying with FAA regulations and ensuring a safe and successful operation. FAA Part 107 regulations require drone pilots to be familiar with visual flight rules, VFR checkpoints, which are used to navigate in the airspace and identify key locations on a sectional chart. VFR checkpoints are visual landmarks or geographic features that can be easily identified from the air, such as mountains, lakes, highways, or other notable features. They are often marked on sectional charts with a small symbol, such as a triangle or a star, and a label indicating the name of the checkpoint. VFR checkpoints can be used to help drone pilots navigate to a specific location during a flight or to maintain orientation and situational awareness in the airspace. For example, a drone pilot might use a VFR checkpoint as a reference point to navigate to a particular point of interest, such as a building or natural feature. Alternatively, a drone pilot might use a VFR checkpoint to ensure that they are maintaining the proper course and altitude during the flight. In order to use VFR checkpoints effectively, drone pilots must be familiar with the symbols and labels used on sectional charts, as well as the geographical features in the area in which they are flying. By using VFR checkpoints in conjunction with other navigational aids, such as GPS or magnetic compasses, drone pilots can ensure safe and successful operations in the airspace. FAA Part 107 regulations require drone pilots to understand the difference between mean sea level, MSL, and above ground level, AGL, which are two altitude references used in aviation. MSL refers to the height of a location above mean sea level, which is the average level of the ocean's surface at a given location over a period of time. MSL is typically used as a reference for setting altimeter settings and navigating in the airspace. AGL, on the other hand, refers to the height of a location above the ground level in that location. AGL is an important reference for drone pilots because they operate at low altitudes and need to maintain a safe distance from the ground and other obstacles. When planning a drone flight, it is important for pilots to consider both MSL and AGL in order to ensure compliance with FAA regulations and maintain safe operations. For example, a drone pilot might need to maintain a minimum altitude above the ground in order to avoid obstacles such as trees, buildings, or power lines. This altitude would be measured in AGL. However, the FAA also sets altitude restrictions based on MSL in certain types of airspace, such as Class B, C, and D airspace, which are designated around airports and other high-traffic areas. Drone pilots operating in these areas must comply with the altitude restrictions set for that airspace, which are measured in MSL. By understanding the difference between MSL and AGL, and how to use both altitude references when planning and executing a drone flight, drone pilots can ensure compliance with FAA regulations and maintain safe and successful operations in the airspace. FAA Part 107 regulations require drone pilots to understand airport operations and radio frequencies in order to ensure safe operations in the airspace. Airports are a critical component of the airspace, and drone pilots must be aware of their location and operations in order to avoid conflicts with the manned aircraft. The FAA publishes airport information in the form of Airport Facility Directory, or AFD, which provides information on airport location, runway configuration, traffic patterns, and communication frequencies. Radio frequencies are used by pilots and air traffic controllers to communicate with each other during flight operations. Different frequencies are used for different types of communication, such as ground control, tower control, approach, and departure. Pilots must be familiar with the appropriate frequencies for their operations and be able to communicate effectively with air traffic controllers. Drone pilots operating in the vicinity of an airport must be familiar with the airport's communication frequencies and follow established procedures for communicating with air traffic controllers. In addition, they must be aware of the airport's traffic patterns and any altitude restrictions or other special procedures that may be in place. By understanding airport operations and radio frequencies, drone pilots can ensure safe and successful operations in the airspace and avoid conflicts with manned aircraft. They must also be able to communicate effectively with air traffic controllers and other pilots in order to maintain situational awareness and comply with FAA regulations. FAA Part 107 regulations require drone pilots to understand isogenic lines, which are used to adjust for magnetic variation when using a magnetic compass for navigation. Isogenic lines are imaginary lines on a chart that connect points of equal magnetic variation. Magnetic variation refers to the difference between magnetic north, the direction that a magnetic compass points, and true north, the direction to the geographic North Pole. This variation changes depending on the location of the Earth's surface and is shown on charts in degrees. When using a magnetic compass for navigation, it is important to adjust for magnetic variation in order to ensure that the compass points in the correct direction. This adjustment is made by adding or subtracting the appropriate number of degrees of magnetic variation to the compass heading. Isogenic lines are used to determine the correct amount of variation to apply based on the location on the chart. Drone pilots must be familiar with the isogenic lines on sectional charts in order to ensure accurate navigation with magnetic compass. They must also be able to adjust for magnetic variation and maintain situational awareness in the airspace in order to avoid conflicts with other aircraft and maintain safe operations. FAA Part 107 regulations require drone pilots to understand maximum elevation figures, MEFs, which are used to ensure safe drone operations in the airspace. MEFs are depicted on sectional charts and show the highest known feature or obstacle in a particular area, including natural features like mountains and man-made features like buildings, antennas, and towers. MEFs are measured in feet above sea level, or MSL, and provide critical information to the drone pilots about the maximum altitude they can safely operate at in a given area. Drone pilots must be familiar with MEFs in the areas they plan to operate in, and must not fly their drones above the MEF altitude without obtaining prior permission or clearance from air traffic control. In addition, drone pilots must ensure that they maintain a safe distance from any obstacle or terrain features and should always fly at an altitude that provides adequate clearance. By understanding MEFs and other key information on sectional charts, drone pilots can ensure safe and successful operations in the airspace while avoiding conflicts with manned aircraft and maintaining compliance with FAA regulations. FAA Part 107 regulations require drone pilots to be familiar with Victor Airways, which are a network of airways used by manned aircraft for navigation in the airspace. Victor airways are depicted on sectional charts as solid magenta lines and are used by pilots to navigate between waypoints and airports. They are designed to provide a safe, efficient route for manned aircraft while also avoiding restricted airspace and other hazards. Drone pilots must be aware of the location of Victor airways in the airspace and must avoid flying their drones within these airways. Drone pilots must be aware of the location of Victor airways in the airspace and must avoid flying their drones within these airways. In addition, drone pilots should maintain situational awareness and ensure that they do not pose a hazard to manned aircraft operating in these airways. By understanding the location and purpose of Victor airways, drone pilots can ensure safe and successful operation in the airspace while avoiding conflicts with manned aircraft and maintaining compliance with FAA regulations. This brings us to the end of the Part 107 Drone Study course. By now, you've learned a lot and have all the necessary knowledge to pass your exam on the first try. Remember, you can always view previous sections, tests, and visual aids. We want to thank you for taking this journey with us and wish you the best of luck as you embark on your exciting career as a commercial drone pilot. Fly safe.